In this lecture, I am going to give you a warning, and that is to never call virtual functions from constructors or destructors. I am going to repeat this. Never call virtual or polymorphic functions either from constructors or destructors, and we're going to explore why. We're going to be using this inheritance hierarchy. We're going to have a base class called base. How creative. We're going to inherit from base and create derived, which is our inherited class. And we're going to be using this to explore why we can't call virtual functions from constructors and destructors. This is what our code is going to look like. The base class is going to have a protected member variable. It's going to have a bunch of virtual functions. We will have a virtual function to set things up, and it is just going to set the value of our member variable to 10. And we're going to have a virtual function called cleanup, which is going to maybe do some cleanup. We're going to see how this works out. We also have a method to get the value, but I don't think we will use this, but you can keep this in if you want. Notice that we are trying to call the setup method from the constructor. And you see that we have a comment that says that this is going to do static binding, but we're going to see why in a minute. So this is our base class. We can derive from this class and create our derived class. We're going to inherit publicly, and we are going to override the methods we have in the base class. We're going to override the setup method. As you see here, we're going to override the cleanup method, and our destructor is also going to be virtual because we are good C++ citizens, and this is the setup we have. Once you have your inheritance hierarchy set up, you're going to do something like this. Because you want polymorphic behavior, you're going to set up a base pointer, and you're going to use that to manage a derived object, and you can do something like this. Now, considering this statement here, I want you to think about the order in which constructors and destructors are going to be called. We have touched on this subject before, and we are going to revisit this because it is really important in terms of calling virtual functions in destructors and destructors. So when we do something like this, the base part of this object is going to be built first. So we are going to call the base constructor first. We're going to set up the base part of us. After that, we're going to set up the derived part of us, and we're going to call the derived constructor. And after the derived part of us is set up, we can use our object like we do always. So we're going to use our object to do whatever it is we want to do. When the time comes for this object to be destroyed, we're going to destroy the derived part first, and then we're going to destroy the base part first. Now that we have considered this order, try to think about the setup when we call a virtual function from a constructor. That's what we're going to look at first. The base constructor is going to be called, but notice that by the time we call the base constructor, the derived part of us won't be set up yet. So if we try to call a virtual function in the base constructor, there won't be a derived part to call the most specialized method for. So the compiler will notice that we don't have a derived part yet. We will be at this stage building the base part. And if we call a virtual polymorphic function, we want the most specific part to be called, which should live in the derived part. But we haven't done the derived part yet. We are still building the base part of us. So the compiler is going to notice that we don't have a derived part, and it is going to call the base version of our virtual function. That's why we said that if you call a virtual function from a constructor or a destructor, you're going to get static binding results. If you call a virtual function, you want the most specific version called, but we don't have that yet in the base part because the derived part haven't been set up. That's why we get static binding results. I hope this makes sense. And we're going to get the same result if we try to call a virtual function from a destructor. If we get to the point where our object needs to be destroyed, the derived part is going to be wiped out first. We're going to be left with a base destructor, and when we hit this base destructor and call a virtual function, that would mean to call the most specialized version of that method, but the derived part of our object has been already wiped out. So this is no longer existent, and we are trying to call a method on this. So the compiler is going to do the next best thing it can do. It is going to call the best version of our virtual function. And again, we are going to get static binding results. That's why it isn't really wise to call a virtual function either from a constructor or a destructor. Now, some of you must be asking, what if I really need to do setup and cleanup in the way that we set up these things in our classes? What if this method is really useful? Maybe it is setting up things we're going to be using in our application. We really need this. And the most logical point to call this is the base constructor. Well, you shouldn't really put these in a constructor. What you could do is maybe call this virtual method on your object directly when the object has finished being a constructor. That's going to be a better place to do this, because if you put that in a constructor or a destructor, you're not going to get dynamic binding results, and that's going to be really bad. So to sum up, calling a virtual function from a constructor or a destructor won't give you polymorphic or dynamic binding results. The call will never go to a more derived class than the currently executing constructor or destructor, and we will get static binding results. This is the idea I want to convey here. And as a guideline, you should never call virtual functions or polymorphic functions from constructors or destructors. If you really need this, the next best thing you can do is to call your virtual functions directly on your object after the object has been properly set up. We can do something like this and call our setup method, and then we can call cleanup when we think that we need to clean up. And you call cleanup after you construct the object, and you call delete after you clean up your object. This is going to do whatever it is you want to do with your polymorphic functions, and the calls to these virtual functions won't be living inside a constructor or a destructor, and this is going to work really well. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is polymorphic functions and destructors. We should really say with constructors and destructors, but this is going to do. We're going to grab our template files and we're going to put them in place. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean up a little bit, remove whatever it is we don't need. And I am just going to put in my classes. I am going to do that in the main CPP file because that's going to be much easier to follow. We have our base class. It is going to have a single member variable called mValue, and we will have a virtual destructor. We will have a bunch of virtual functions. One is going to be setup, which is going to set our value. The other is going to be cleanup, which is going to be doing some cleanup here. We will also have a getValue method, which will get this value and print it out if we want, but it is really not that useful here. We will also create a derived class, which is going to inherit publicly from base. It is not going to have its own member variable. All it's going to do is set up a bunch of overrides for the virtual functions we have in the base class. We're going to override setup, and in derived, we're going to set our value to 100, and we're going to clean up and put a message that we are cleaning up here. Once we have this set up, we can head over in the main function and set up a base pointer, which is going to be managing a derived object. A classic setup for polymorphic behavior. So we're going to say base, and we're going to say pbase, and we're going to say equals new derived. This is going to give us our object, which is managed by a base pointer. And one thing I didn't show you is that we are calling the setup virtual function from the base constructor. This is what we want to see. We want to see what is happening here. Now, if we call this setup function, we would expect polymorphism to kick in because this is a virtual function. If the derived part is available, we will call the most specific setup function, and that would set up the value to be 100 here. If we get the value, that's what we would get. Let's see what we get here if we try to get the value that we have in this object here. So we will get auto value, and we're going to say pbase get value. We have this function here, and we will try to print this out. Okay, this is something we can do in our C++ program, and we're going to see the value we get. Because we are calling this virtual function, we expect polymorphism to kick in, and if polymorphism polymorphism kicks in, we're going to call the most specialized version of our virtual function here. That would be the override we have in derived, and that would give us 100. So one would get 100 printed out here. But let's see what we get. We're going to run this through GCC, our favorite compiler. The build is going to be good. We can clear or bring up a PowerShell window. We're going to clear now and run Rooster. We're going to see that the base constructor is going to be called, base setup was called. You see, we called the base version of this, and the derived constructor will be called. And we're going to see that the value doesn't exist. Oh, we didn't put the value out. Let's do that. My bad here. We're going to build again. We're going to use GCC to build. And the build is good. We can clear and run Rooster. Now we see that the base setup method was called and set the value to be 10. And we are really getting static binding results because we are calling the setup method from the base class and the base version is being called. So this is classic static binding behavior. But we want polymorphic behavior to be working here. But we just saw the reason why this is in the slides. By the time we call this virtual function, we haven't set up the derived part of us yet. And we have no way to call this virtual function which lives in the derived part of us. So the compiler is going to do the next best thing it can do. It's going to call the base version of this method, and we are going to get static binding results. And we are going to get the same results if we try to call a virtual function from the destructor. For example, if we go in our destructor here, let's see if we can find it. We're going to go in our destructor here and say this and say cleanup. You can do something like this. And you're going to see that the cleanup version we call is the base version of cleanup. And we don't really want to do something like this. We want the most derived cleanup version to be called, but we won't get that because by the moment we call this virtual function from our base class, the derived part will already have been wiped out, so it won't be available. And the compiler will do the next best thing it can do. It is going to call the base version of our cleanup function here. I hope this makes sense. Again, to really drive this home, I realize this can be confusing to many people, especially beginners. If we are calling a virtual function from a constructor, we will call that virtual function when we hit the base constructor. But by the time we hit the base constructor, the derived part of us hasn't been constructed yet. So if we try to call a polymorphic function, needing to call the derived implementation, that won't be available and the compiler will do the next best thing it can do. It is going to call the base version. The same phenomenon is going to happen in the destructor. When we are done using our object, we will destroy the derived part information first. And when we hit the base destructor and call a virtual function, there won't be a most specialized version of the virtual function because the derived part has been already destroyed and it doesn't exist anymore. So if we call a virtual function from the base destructor, we will get the base version called, and this will give us static binding behavior. This is what we are experiencing here. Okay, so let's try and run this program and see what we get. We will print our value here, which is going to give us static binding results, but we want to see which version of cleanup is called. This is what we want to see here. We're going to run the task to build with GCC. The build is going to be good as usual. We're going to clear and run Rooster. And we're going to see base constructor called, derived constructor called, and we're going to have a value, which is a junk value because we never initialized this value, but we don't see our destructors called. What is going on here? Let's investigate this a little more. The reason is we are not explicitly releasing this memory here through the base pointer. Let's do that. We're going to delete pbase here and we're going to run again. We're going to build with GCC. Now our destructors should be called. We're going to run Rooster and we are going to see that the base cleanup version was called, and again this is giving us static binding results. You don't want something like this. So if you want to get this behavior, I would advise not to call the cleanup or setup functions inside constructors or destructors. And that's the guideline I gave in the slides. You should really never call virtual functions either from constructors or destructors, especially if you are doing this from a parent class, hoping to get the most specific virtual function called through polymorphism. If you want to do that, the best thing you can do is to call the cleanup functions and is to call the setup and cleanup functions after your object has been properly constructed or before your object gets to be destroyed. So what you can do here is call the setup method on the pbase pointer here. Let's do that, and we're going to call setup. This is going to call our virtual function, and we are going to get polymorphic behavior. This is going to print a 100 as we expect, because it will call the derived version of setup here. And before we delete our object, we will need to call the cleanup function if we need to do some custom cleanup here. So I'm going to say base and call the cleanup function, and this is going to give us the behavior we want. We're going to build our program, pass this through GCC. The build is going to be good. We can clear and run rooster. And we are going to see that base constructor was called, derived constructor was called. We will call the derived version of setup. Our value will be 100. And when we get to release or clean up our memory, the derived version of cleanup will be called. And then we will destroy the derived part of us. And then we will destroy the base part of us. And this is going to work in line with the behavior we are familiar with polymorphism, and this is really cool. So this is what you should do. You should never call virtual functions from destructors and constructors, because that's going to give you static binding results, and what you want in this case is really dynamic binding behavior. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about the type ID operator that can come in handy, especially if you want to debug polymorphic code in your C++ program. Go ahead and finish up here and meet me there.